Hey, what's going on, y'all? So this is Ricardo Billanzar, and welcome back to the channel, Lessons with Ricardo. Today we're gonna be doing, uh, what? Yeah, DNS. That's what it is. All right, y'all. So thank you so much for joining the channel. So today we're covering DNS. If you don't know what that is, perfectly fine. We're going to cover that in addition to why you would want to learn more about it and what kind of benefits you can get from doing your own DNS server. Now, first of all, DNS stands for Domain Name System. I'll tell you, my use case came about because I really wanted to get into doing my own email server. And this is like a long, long time coming type of journey for me. I don't know why, but I think almost 10 years ago, I decided I wanted to do my own email server. And while exploring that, I realized that I needed to do some reverse DNS type of setup, which requires a PTR record to make it a viable email server. I know I'm saying a lot right now, but just wanted to let you know that was my use case for getting into it. But since then, I had to really dig in deep into what it is and how it works. And I find it to be really, really fascinating, especially considering recent knowledge gains I've had around penetration testing and leveraging DNS for actually exploiting targets. But that being said, let's take a step back real quick. So first of all, if you've been on this journey with me, you're familiar with the diagram I'm about to put on the screen now. Let me go ahead and share my screen. So this diagram is my grand scheme layout of the entire infrastructure I want to put in play in my home lab and also in my cyber range. So for those who are not familiar, it covers a lot of components, but we've already covered Security Onion. We've also done the FIM, which was supported through the installation of Waza, which is a SIM, also an XDR tool. Within all of that, it has what they call a FIM, a file integrity manager. So we covered these 2 points. Next on my list was actually going to be the SOA DNS. Now, SOA I put in there is actually regularly known as authoritative DNS. I put source of authority DNS, that's the SOA portion of it. But either way, this is the DNS that is going to be hosting the zone files, and we'll get into that in just a moment here. So that's where we are, and this is important to me because it is going to be hosting the domains that will then host the tools and applications as well as our DOH, which is the DNS over HTTPS. So for me, this is a critical installation. That's why I wanted to do this one next. All right, so that being explained where we are in our overall plan of building a home lab, let's talk about DNS. What is DNS? So DNS is domain name system. It is the backbone of the internet for most of us. Not literally, but if we didn't have DNS, many of us probably would give up on the internet. Let me show you what I mean. Actually, I was going to tell you about it, but let me actually show you. Let me pull up my terminal here, and I'm going to run a quick tool here called Dig. Now, Dig is a tool and that resolves name servers or names we provided, and we'll get more into that in just a second. I just want to show you what the web looks like to computers and not to people. So as I'm doing this, I'm gonna go ahead and try to zoom in just for a moment, make it a little bigger for you. As I'm doing this, just let me explain. So domain name system is responsible for translating or converting a domain name such as google.com, which we'll type in now, into IP addresses. An IP address comes in two flavors or two versions. That's going to be IPv4, which has four numbers. They're called octets, and they're separated by periods. Okay, so you have four numbers, three periods. That's IPv4. IPv6 is a much longer combination of numbers and letters along with semicolons. Oh, sorry, not semicolons, colons. And we're not going to show that now, but I'm just going to explain that it converts these names that you see on the screen here, google.com, into something like these IPv4 IP addresses. So this is what I meant by without DNS, most of us would give up on the internet. How many of you will want to go around having to memorize at minimum four, I'm sorry, six, I don't know where four came from, but at minimum 6 different IP addresses to get to google.com. Reason why you have so many is because it kind of does like a load balancing. It's whatever one responds first is the one you'll be leveraging when you go to this domain. And to show you what this looks like and how it works to a computer, let's just pull up a browser. Yes, we'll get into the DNS service here, but I'm just going to paste this in, and there you go. You type in the IP address, or you paste in the IP address, and you get google.com. So this is what DNS is doing for us, but the question is, how does it actually work? And we have to explore that because we're going to be setting one up ourselves. So let's take a peek at the Bind9 documentation. I chose this because, one, I'm more familiar with this DNS setup. Um, and all two, I think the documentation is really well laid out, and they give us little diagrams, kind of a cheat sheet for me. And this is where we'll start. So when it comes to DNS, it's divided into 3 separate layers. Really, a lot of this stuff, really, you don't have to be bothered with, but it's good to know. You have the root DNS layer, the TLD, which stands for top level domain DNS, and then you have the user DNS layer. Now, what you're probably not too concerned about is the root level, which is just a period. Okay. Now, it's important when we start setting up our DNS, our authoritative DNS, that we understand this because we do want to specify every layer of DNS when giving the name of the domain we're going to be hosting. Okay, so the root is the period. Now, what you're probably most familiar with are these .com. So these are the top level domains. You have .com, .org, .us, .uk. A whole mess of these exist, and they pretty much feel like they expand almost every day when you go into any domain registrar. If you don't know what a domain registrar is, uh, I'm not hosted by, I'm not sponsored by any of these, but the most popular one is probably GoDaddy. So this is a registrar where you go and you purchase a domain that you want to host websites, email services, whatever it may be on the open web. And it's important to know this because this is the body organization that's responsible for reporting who owns which of these TLD domains. Now, the user level is when you start getting into the Google portion of it, right? So if you break down google.com, which I'll flip over here, we have an invisible period, which is on the end, which is root. You have the .com, which is the top level domain, and then the user level, the one we're responsible for managing, is Google. Now, there is something called a subdomain, which is, I'll show you here. If we type in, let's clear the screen, we have something like www.google.com. Now we have the invisible period, and actually I'm curious if I put the period in, what happens. So you have the root level, and it reads right to left, obviously, and then you have the .com, and then you have the user level, and you have the subdomain. Now, this is all used to host different ways of different content and stuff like that, but this is the breakdown of DNS system, and yeah, it does work. So the invisible dot is always understood to be there because it is the starting point of all DNS. Now that you understand the layout of DNS, one thing I do want to mention is it has a standard port. Now, we're going to be getting into ports when we start getting more into the pen testing and actually doing exercises throughout our environment. But it's good to understand what a port is and what port is associated with this particular, what they call a protocol, DNS protocol. It's going to be port 53. Now, it runs on both TCP as well as UDP, and I'll show that when we start setting up. It's a lot now, but we're getting to there, okay? But just want to give you a layout. So that's what we'll be doing in the video. All right, so continuing on, the biggest thing I think is to understand the different components of DNS. Now you know what DNS is. Now, the components start with, and I'm going to start with the user side of things. The users, such as yourself and myself, we're going to use something like a browser of sorts, whether it be text-based or GUI-based like Chrome or something like that. And it's going to make a call out to what we call a stub resolver. Resolver's responsibility in this entire layout and how DNS works is it is meant to query or to ask the authoritative server what IP address goes with which name. So when I ran dig, my stub resolver looked to see if it knew locally on my machine what the IP addresses are. Now let me see if I can actually see who answered. I haven't looked at this yet, but I see it looks like I had 6 answers, which represent these here. There was one query. Now oh, here it is. So the server that responded is this server here. So this is a server that responded with information, which is not the local stub server, stub resolver, but is actually um, my standard resolver. So I have multiple layers. You have the stub resolver, which looks at the host file locally. Then you have the resolver, which is probably on the gateway level or the highest level of your internal network. And then you also have resolvers out on the web you can use, such as Google's resolver or Cloudflare resolver. But either way, their responsibility is to give you will send the request out and then return the results. Okay. So now once we step past the client side of things or the user side of things, we get into the actual authoritative servers. And that's what we just looked at a moment ago, is where we host the zone files or the different levels. These are all considered SOA, source of authority servers at this point, because they're hosting the zone files. All right, so we covered the stub resolver, the DNS resolver here, which is the broader one, right? And then the actual different levels of authoritative servers after that. That's exactly how it works. And I think that covers most of it here. The next thing here is to understand what the zone file is. I think the best way to do that is to try to find it in here. Let me see if I can scroll down. I believe that. Oh, you know what? Actually, next to understand is the resolver. Ignore the proxy here, right? The most important thing I think to point out here is that the SOA, source of authority or authoritative DNS servers, are broken into 2 kinds. You have primary and you have the secondary. The primary is where you write the files. They are readable, human readable files. And then the secondary is typically what you point your domain registrar information to. So what happens is it will stay in sync with or it being the secondary or slave authoritative servers will be in sync with the primary one that you actually configure the zone files. It will stay in sync with those using tsig, tkey, or something like that you see down here to transfer the zones between the 2 different type of servers. Not really between, it's a one-way transfer. The authoritative primary transfers to the secondary. And that's how that relationship works. Important thing to know when we start setting, as I mentioned before, to get into the setup videos. All right, so I think that's it, except for the zone files. So, a zone file. Let me pull on the screen here. All right, so what we're looking at here is a zone file. This is the last part I want to cover. The reason why I'm covering this is because this is what you're going to be working with. This is what will contain your actual domain names, subdomains, whatever it may be, and their associated IP addresses that you want it to point to. Now, the IP address does not have to be local. It can be a IP address out on the open web, such as a VPS or virtual private server that you may be purchasing, or it could be another internet service provider you may have, whether it be in the house or somewhere else. So it's really interesting how this part works, and you can get really creative in how you direct traffic, which when you look at it that way, directing traffic on the web is pretty powerful, right? That is why it's so interesting and so fun to get to learn more about this part of it, because you get to figure out, if I, for instance, you are purchasing a product, right? Like, what's the popular one that you get a domain name, but it's not actually a domain name you want? You get into the area, I think Wix, and there's some other products out there that do something similar to that. But you may get like one of those free domain names, but then you want to convert it over to another domain name later. Now, instead of trying to figure out how to do all the conversion and stuff like that, once you start hosting your own DNS server, what you can do is learn about resource records in your zone file and creating a resource record called a CNAME, which is down here at the bottom, where you just direct whatever is pointing to that subdomain of your purchase domain to another domain. Now you have to own both of them to control each of these records. So this is pretty powerful stuff here. Keep that in mind. All right, so I mentioned resource records. So in the zone file, you have a couple components here. First, we have, these are comments. Anything with a semicolon is a comment. But first you have something like the total time to live, so the TTL, and this states a certain number, right? It could be a digit, it could be a digit with a letter like this representing 2 days, and then you, but it's a different combination of them you'll see out there. Also, you have the origin. You're stating that the domain you're managing, in this example, it is example.com, with the root being the period at the very end. And it just states that whenever you, this is the origin, so whenever you see an @ sign, it is substituted by the protocol itself to mean this. So once you write this once, you can use @ sign to represent the origin. Pretty cool feature built into the protocol. Actually, now that I think about it, a really good way to learn a lot about this outside of reading this documentation on Bind 9 is learn about RFCs, requests for comments. There is an RFC for pretty much every technical protocol procedure we have, and there is one for DNS. I'll post it in the description below. I actually did read it when I was learning this. I was pretty intrigued by it. You may be as well. Now, in addition to that, you have some statements about, first is SOA, so source of authority, stating that, hey, this is one of the, I guess you would say, name servers and a contact for this, okay? And then you have what the really important part is, the serial number. Now, in the setup of using Unix-based systems running bind like this, you're going to have a serial number you have to input. Now, I say have to because it is critical to making sure your setup works. And we'll get into that when we start deploying. But this actually counts as a time stamp. And the DNS protocol looks for this to know if anything has been updated. Very, very important. I spent many hours researching why my DNS was not updating to the rest of the world, was not propagating to the rest of the world. And the reason I stumbled across was there is a default time that it runs through, but if you don't change this, it won't do an immediate update. Very key to this. And then, of course, some of the refresh, some of the other metrics here, some of the other settings here that you will want to tweak as you go through this. Now, I say as you go through this because there are going to be things such as setting up security behind this that will have certain requirements that will show up in your logs telling you that, hey, this needs to be changed. So keep that in mind. We'll see that later. And then these are what they call resource records. Now, the resource record technically is this part here. The NS stands for name server, where you specify the name servers themselves. But there are different type of resource records. You have MX, which is a mail server, NS is name server, and so on. A record, CNAME, all of these are different resource records. They're also abbreviated as RR. And that's it. That makes up the zone file. So you have the statement of how long this should last. You have the statement of your zone of your domain itself, and then you also have the statement of the serial number and different other parameters that are associated with that domain and the zone file itself. And then you have the resource records themselves, which come in a variety of different options. In fact, this is going to be part of the exploitation using DNS we'll explore later when we start doing some of the exercise of pen testing. And that's pretty much it, y'all. So that's what I wanted to cover as to what DNS is, why it is needed, and if you're following along with my particular journey, you really need to have this so that you can create the reverse lookup zones as well to make your email server run as expected with the rest of the world. If you enjoy this, please make sure you like it, you subscribe also, you comment, and you share. Thank you so much for watching. Let's continue the journey together. Bye.